Okay, question is, here's another set. Does this set constitute a basis? Yeah, of course, the basis of P3. Well, again, got to be linearly independent. If it isn't, we're done. It's not a basis.
All right, Taylor.
Okay? Suppose this is 0. Does it follow that C1, C2, and C3 all have to be 0? Well, we can rearrange this. We've got C3 plus C1 x squared plus the only x we have is with C3x plus C1 plus 2C2 equals 0. Just rearranging this so we have our multiples of x squared, x, and our constant number, right? Okay, now if this is 0, that means C3 plus C1 has to be 0, C3 has to be 0, and C1 plus 2C2 has to be 0. Okay? How do you solve that system of equations? Well, C3 is 0, right? Which means that 0 plus C1 is 0. So C1 is 0. So C1 is 0, meaning 2C2 is 0, so C2 is 0, right? Okay? Does it span? Well, that comes down to the C1 times 1 plus x squared plus C2 times 2 plus C3 times x squared plus x equals ax squared plus bx plus c, right? Okay. Well, we have the same thing on the left-hand side here that we had here, right? So that okay. We get these equations. We just rearrange this to this form, except that we have an ax squared plus bx plus c instead of a 0, right? So whatever is multiplying x squared has to be equal to a. That's all. You can verify the solution is C3 equals b, C1 equals a minus b, and C2 equals, careful, c minus a plus b over 2. And if I solve that wrong, solve it yourself. Okay? And of course, this could be set up as an augmented matrix and reduced, right? So could this. And the bottom line then is, as long as the augmented matrix, well, let's look at what the augmented matrix does. Okay? So let's look at how the augmented matrix would address these questions, because that's something that's really, really worth knowing.